Today we're going to be talking about multiplying polynomials, and so this is going to take multiple different forms. We might have a monomial times some sort of binomial or trinomial. We could be having binomials times binomials or binomials times trinomials, things like that, but we're multiplying different polynomials together. Two things we want to remember: we're going to use the distributive property that we've used in the past, and then we're also going to, when we do this, we're going to multiply the coefficients and add the exponents of variables with the same base. So what I mean there, if we're taking x to the third times x squared, what that really means we have going is x to the third is x times x times x, and x squared is x times x. So here, this, if we have x times x times x times x times x, that would be x to the fifth power. So what we're doing here is taking those exponents and we're adding them together. So as we distribute in, we're adding the exponents, but we're just multiplying the coefficients. The numbers act like numbers. So let's take a look here. So we're going to multiply, and then we're going to write our answer in standard form. Okay, so we'll refresh your memory with that here shortly. So we have 4y squared multiplied by the quantity 5y to the fourth minus 3y squared plus 2. We see something outside of parentheses, so we're going to distribute that in. 4y squared times 5y to the fourth is, well, 5 and 4 is 20, and then here we have y squared times y to the fourth, so that's going to be y to the sixth power because we add those exponents together. Distributing in, we have 4y squared times negative 3y squared, so that would give us negative 12y to the fourth. Multiply coefficients, add exponents together. And 4y squared times 2, we're going to multiply the numbers, so that would give us 8, and there are no exponents to add. So it said multiply and write in standard form. So here we have to look, are there any like terms to combine, which there aren't, and then do our exponents count down from highest to lowest, which they do. So this is the answer to this question. The next one here, we have 8m times the quantity m plus 6 minus 5m squared times the quantity m minus 1. This 8m is going to distribute just into this next set of parentheses here. So 8m times m. The 8 gets multiplied by, there's an invisible 1 in front of that. And the exponents here, we have m to the first and m to the first. So if we add those, we would have m squared. M times m is m squared. And we've seen that before. 8m times 6 would give us 48m. That's been distributed to everything, so we're moving on. Negative 5m squared times m, again that's m to the first, would give us negative 5m to the third power. And negative 5m squared times negative 1 would give us a positive 5m squared. That's multiplying. Standard form. We need to make sure that we're putting them in the proper order. So the highest exponent that I see here is this negative 5m to the third, so we're going to keep the negative with it. Then we have 8m squared and 5m squared. Those are like terms for us to work on. So that would be plus 13m squared. And then the last thing we have here is the 48m that has nobody to combine with. And so then that would be our answer. So that's a monomial times some sort of polynomial using, combining like terms, things of that nature. So let's take a look here then at what happens if we have a binomial times a binomial. So we're going to do the same general steps again. So here we're going to take the quantity 7x plus 4 and multiply it by the quantity 2x minus 4. So we're going to distribute this. 7x gets distributed to 2x. Well, that's going to give us 14x squared. And 7x times negative 4 gives us negative 28x. So that 7x gets multiplied to the entire second parenthesis here. We've shared that with everything. Now we're going to take this positive 4 and distribute it. So 4 multiplies by 2x to give us 8x. And 4 multiplies by negative 4 to give us negative 16. So you're taking this first piece and it distributes to everything. The second piece gets distributed to everything. And now we're going to combine like terms and making sure that we're writing it in standard form. So 14x squared is going to go first. We have negative 28x and positive 8x. Those are like terms here in the middle. So we're going to combine those to get negative 20x. And then this gives us a negative 16. There's our answer for that question. So let's go ahead and try one like this again. So we have 4x plus 1 times the quantity 2x squared minus 1. 4x is going to get distributed to everything in the second parentheses first. So 4x times 2x squared, keeping in mind that's a 1 there, that would give us 8x to the third. And 4x times negative 1 is a negative 4x. That has been distributed to everything, so we're moving on here. 1 gets distributed to 2x squared, which would give us 2x squared. 1 gets multiplied to negative 1 and gives us minus 1, or negative 1. So we're going to combine like terms, write it in standard form. Here we go, highest exponent, so we have 8x to the third, plus 2x squared, minus 4x, and then minus 1 is our answer. Okay? So let's keep moving on. Oops. We have the quantity 3x plus 7 times the quantity 3x minus 7. So we're going to look to see what happens here. So 3x times 3x is 9x squared. 3x times negative 7 is negative 21x. 7 times 3x is positive 21x. And 7 times a negative 7 is a negative 49. Now if we work on putting this in standard form, we have 9x squared. Here are like terms in the middle. What happens to those? So those go away. And we have minus 49. So this is a special type of question. What do you notice about these two parentheses? They're the exact same thing. You just have one with a positive sign in between them and one with a negative sign in between them. When we have this is what we call conjugates. Okay, conjugates are the exact same binomial, one positive, one negative, and that's going to help us eliminate those or cancel out those middle terms to be left with just a binomial. All right, so what happens if we have something like 4x plus 5, that quantity is squared? So let's talk about what it means to be squared for a second. If I give you 3 squared, that means that you're taking 3 and multiplying it by itself. So if we have 4x plus 5 squared, we're going to take that and we're going to multiply it by itself. Okay, so you should be working on writing it twice or imagining it being written twice before we multiply. So 4x times 4x then is 16x squared. 4x times 5 is 20x. 5 times 4x is 20x. And then 5 times 5 is a positive 25. So in this case, when we have a binomial squared, we have 16x squared. These middle terms are like terms, but unlike the conjugates, they add together. Okay, they're not going to go away here. And then we have plus 25. So there's our answer for this question. Let's look at one more where we're taking a binomial and multiplying it by a trinomial. So we have the quantity x minus 5 times the quantity 2x squared minus 7x minus 2. So these work the exact same way. We're taking this x and we're distributing it into every piece over here. So x times 2x squared would give us 2x to the third power because we add those exponents. X times negative 7x would give us negative 7x squared. And x times negative 2 is negative 2x. This x has now been distributed to everything. Instead of just distributing it to 2 things, we distribute it to 3 because that's how many are there. So since that's all done, we're going to take this negative 5 now and distribute it into everything. So negative 5 times 2x squared is negative 10x squared. The exponents aren't going to change at all because we're not multiplying any number or any variables there. Negative 5 times negative 7x is a positive 35x. And negative 5 times negative 2 is a positive 10. So now that we have this, we're going to put it into standard form. So we have 2x cubed. Our x squareds are like terms, so that's going to be minus 17x squared or negative 17x squared. Our x's are like terms. So that means we're going to have a positive 33x. And then we have that positive 10 that's just hanging out by itself. So one thing to keep in mind, don't forget, you need to make sure that you're multiplying coefficients. Remember, the coefficient is the number in front of the variable or just the number itself. So you're going to multiply the coefficients and add the exponents together if they have the same variable, which these all did. And an easy way to see how many terms you should have before you combine is to count how many things you got. So we had 2 terms times 2 terms. Well, 2 times 2 is 4. So we had 1, 2, 3, 4 terms before we combined those like terms. Down here we had 2 times 3, so 2 times 3 is 6. We had 1, 2, 3, 4, 5, 6 terms before we combined. So that's an easy way to kind of make sure that you at least have the correct number of terms.